Alright, welcome to our next video. I actually started this video with a warm-up problem based on what we've been doing in class today. I'd like you to try to find the x-intercepts of this quadratic equation. So you go ahead and pause it and go ahead and try that. While you do that, I'm going to toss the football around, wait for you to finish. When you're finished, come back. Alright, you're back. We're looking for x-intercepts here, so we know our y value is going to be 0. So our first step here is to make the y value 0. And now we learned yesterday a way to solve this equation called factoring, where we are breaking this quadratic down into two separate factors. Basically doing FOIL backwards, or thinking the opposite of the distributive property. To get x squared, x times x will work here. What you may have noticed, and I don't know if we really said this specifically yesterday, but we're going to today, if you need two numbers here that are multiplied to give you a positive 6 at the end, both of these have to have the same sign. Now you need a positive times a positive to get a positive 6, or negative times a negative to get a positive 6. So that's a helpful little trick that we're going to look at today. Here we need two numbers that have a product of positive 6. Now notice when I do the FOIL, when I do my outer and my inner parts, I'm looking for a minus 5x. So I would expect that both of these signs would be negatives. And then 1 times 6 would give me 6. But I think you'll notice when you do the outer and the inner, 1 and 6 don't work. 2 and 3 do work. X minus 2 and x minus 3 are our factors here. Because if I FOIL this back, I get x times a negative 3, negative 3x, negative 2 times x, negative 2x, and I get that negative 5x in the middle that I'm looking for. So I haven't found the x-intercepts yet, but I've found factors. Remember that the product of these two factors has to equal 0. Well, that means one of these factors has to equal 0. So either x minus 2 is 0, in which case x is 2, or x minus 3 is 0, in which case x is 3. And so my x-intercepts, if I were graphing this equation, would be at x equals 2 and x equals 3. Those would be the places where I cross the x-axis. All right? So I want to go back and kind of write down what we mentioned about that trick here. What I have here is your generic, your standard form for a quadratic equation, your ax squared plus bx plus c. And as we factor things, looking at the signs in the equation can be helpful. For example, if you look at the last sign in this equation, this is a plus in this case. If this number, or if this sign is a positive, then the signs of your factors are the same. You have a plus number at the end of there, the factors will have the same sign. They'll either both be pluses or both be minuses. Right? How do I know whether they're both pluses or both minuses? I look at this sign. Right? So this sign tells me that the signs of my factors will be the same. This tells me whether they'll both be pluses or both be minuses. Right? Like in our example, we go back and look. This is a plus. That tells me the signs of my factors will be the same. This tells me they'll both be negatives. They'll both be minus. So I know just from looking at the problem, if I'm going to factor this, the factors will be x minus a number and x minus another number. All right? So again, this tells me the signs are the same. This tells me what they are. They're the same here. They're both minuses. All right? If I had an equation with a plus here, like I have in this example, these would both be pluses. Right? This would tell me the signs are the same. This would tell me they're both plus. Right? So a little trick that can help you cut down on the number of guess and checks. Some people get getting frustrated with how many different possibilities you have and the trial and error that you have to do. That's a nice little trick that will help you out. I have a new problem for us to look at together today. We're supposed to solve this equation for x. Now, that idea, that little trick that I just showed you doesn't really apply here. Because you think, all right, well, I go break down my factors. But now I've got a minus sign at the end, right? So I need certainly x times x to give me x squared. But if I need to multiply two numbers and get a negative, those signs have to be different. I have to have a positive and a negative in there, right? So the signs in my factors will have to have a positive number and a negative number, right? Then I think, well, different ways to get 21. 1 times 21, 3 times 7. Guess that's it. But what you'll find is now it's important that the order of those numbers. So for example, let's say I do 3 times 7 here. If I try to FOIL that, notice I'll get x times a negative 7, the negative 7x, positive 3 times an x. I get negative 4x. That's not what I'm looking for. I'm looking for a positive 4x. So this is not the correct factoring, right? These aren't the factors. Really close though, because we've got the 4, we just don't have the right sign. We want a positive 4x. If you switch where those signs are, you'll get that positive 4x. So this didn't work, but if I turn this into x plus 7 and x minus 3, now when I FOIL, my outer, x times negative 3, my inner, positive 7 times x, and I get that positive 4x that I'm looking for in the original problem. So these are my factors. Just like we did yesterday, now to find the x-intercepts, we're going to take each of those factors, we're going to set them equal to 0 separately. So x plus 7 could be 0, which means x is negative 7. Or x minus 3 is 0, which means that x is 3. 2 x-intercepts here. Again, we've seen 2 x-intercepts the majority of the time so far. So if I can go back and talk about the basic idea, you know, if I look at this general form, we said if this last sign's a plus, the signs of my factors will be the same. If that last sign's a negative, the signs of those factors are going to be, guess what? They're going to be different. So as I go to start trying to factor one of these equations, I should start by looking at the signs. If this sign's a plus, I know the signs of my factors will be the same. I know they'll be the same as this sign, right? This will tell me they're the same. This will tell me what they are. If this last sign's a minus, if I've got a minus a number there, the signs of my factors are going to be different, right? And that's like the example that we just saw, okay? So that's a very helpful thing. If you didn't write this down, go ahead and write this down now. And I'll even say the signs of the factor are the same as whatever one goes here. That's a really helpful trick, and it'll help you cut down on the amount of guessing and checking that you're doing. Okay. All right, so we've got the example we just went through. Here's our next example. That's not our next example. I don't know how that got in there. That's our next example. Find the solutions. X squared minus 2x equals 35. What I want to mention about this problem, I'm going to let you try it on your own here in a sec. It's really important before we start trying to factor, we need our equation to equal 0. Because that last step where we set each of the factors equal to 0 separately, it's important that our factors are set equal to 0. So before I start trying to break this down into factors, I need to subtract the 35. Subtract 35 from both sides. That will make the right side equal to 0. And we'll have x squared minus 2x minus 35 equals 0. First step, always make sure your equation is equal to 0. Okay? You go ahead and pause and try this. All right? Now, we think about our factors. X times x to give me x squared, for sure. Now, think about our signs. This is a minus. That tells me my signs will be different. All right? Whether you put the plus or the minus first doesn't matter. I'll do minus and plus this time just to mix it up. As long as you have each of those signs there, you're fine. All right, now I need something times something to give me 35. 1 times 35, 5 times 7. Remember the reverse of those work as well. And hopefully you did some guessing and checking until you found the proper factors, which are negative 7 and positive 5. Again, think about your outer and your inner terms. Positive 5x, negative 7x. There's that negative 2x that we're looking for in the problem. All right? So I knew the signs would be different. Once the signs are different, this doesn't matter too much. Find my x-intercepts, find my solutions, and those all mean the same thing. Solutions, x-intercepts, we'll call them zeros. All those mean the same thing. Set our factors equal to 0. That's why we have to subtract that 35 at the beginning, so that our equation always equals 0. Add 7, I get x is 7. Subtract 5, I get x is negative 5, and those are my solutions. Okay? So that's the idea of factoring. And again, we'll continue to practice this. Now that you know that trick with the signs, I think it will help you speed along the process of finding x-intercepts and finding solutions. All right?